So this is going to be assembly of the frame. For the frame, you need the bits listed. There are two options for how you want to do it, how you can do it. There's one option that uses these little angles, which is what I'm going to do, which look a bit like this. So there's one option for using those. The alternative is to use something like this. This is just a sort of L-shape plate, and that will it might form a better frame, possibly. It might be easier to line, I'm not exactly sure, but there's two options. This one does require more fixings, but this one is maybe a bit more difficult to assemble. Today I'm going to be using these little angle pieces and assembling it by the sort of compression through the what's-it. As nuts, we're going to be using these. These are a sort of pre-assembly nut, if you will, as opposed to something like this, which is a post-fit assembly nut. So yes, we have two assembly types of nuts. If you want to use the plastic versions, which I don't recommend, they look a bit like that. A sort of similar version, work in a slightly different way, but the plastic one's really not as strong, especially if you start to put any sort of stress on the frame if you're moving it about. Then the plastic ones are just going to sort of fail quite quickly. Well, they won't give you the precision that you need. Whereas the metal ones, once you get it in with a bit of Loctite, so the Loctite will basically make sure that the screw doesn't come out. So due to vibration, they can sometimes come loose. Bit of Loctite, just literally tiniest blob, will keep it in there and it won't come out, and happy days. Then you have a nice rigid frame off which to build the rest of your printer. Sorry for the slightly shaky hands. So that's all that covered. Now we can get on with actually building it. With the instructions at the moment, as I'm building it, there aren't any actual assembly instructions. There's just what it should look like when you're done. But these and these and these, with that image, I mean, it's probably quite difficult to go wrong. I've put a dimension here for the reference of how high that bottom bar needs to be. The reason I've used 20 is, well, among other things, it's an easy dimension to use because these are 20 by 20 and your extrusions are also 20 by 20. So that will mean it's easy to get right, hopefully. So each one is marked. You can see each one is marked. So the 4 is this one, this one, this one, this one. 2 is this one, this one, this one, and this one. And 3 is that one, that one, that one, that one. Obviously, if you get them wrong, then it won't be well, it's not a square. Cube, it's not a cube, it's a cuboid sort of shape with legs off the bottom. But if you get it wrong, then it won't go together. So it's difficult to get wrong because it won't go together if you do. So we'll start by doing one whole side, a sort of flat side, and then the other flat side, and then we'll put the connecting beams in after that. So we'll end up with two bits like this, and then the connecting frames that sort of go across. Now during that process, we also want to try and put in some more of these slot nuts, because although we can use the post-fit assembly T-slot nuts, they're a bit of a pain. They're not ideal, so we want to try and get these in as much as possible, which means during assembly we're going to be trying to get them in the right places, and yeah, things like that. So what does one side look like? Well, always formed of two of the longer legs. These are the 440 length, and then this face will be, we'll do a 400 face, shall we? So 400 will be one up the top like that, and one down the bottom like that. We then need angles in each corner, like so, and further angles that point up like this, and that will form the rest of the frame. To assemble them, you take a slot nut, slide it in the end, over that, one of these, a bit of Loctite, and get it in. You can move it a little bit once it's in. So don't worry too much about getting it in the right place as you do it. You can obviously loosen the screw, slide it up and down as needed. So we're going to leave these ones for now. We're going to just do the flat frame. Start just that. I'm going to keep this drawing here in front of me just so I don't spill the Loctite on the table by accident. It might actually be easier to assemble these separately, so let's try that. So literally with this Loctite, you literally just want a small blob, so you know, like that, through the bracket and then the nut on the back. And as that dries, that will form a sort of like a plastic, which just makes sure that it doesn't all come loose. For assembly here, I've got two different sort of screws. I've got the main Allen key, which I use to tighten things very tightly, and the smaller, well, they're about the same size. They're both the same, I think they're 3 mil Allen heads. This one I use for most of the assembly, but this one I use to make it tight at the end. Just because this is a bit easier to handle and a bit easier because you can just rotate it continually rather than the normal Allen key thing, which you cannot. So that's sort of quite easy to move. I might go ahead and do that. So if we assemble these corners on their own, how about that for a way to start? So the quantities will always be on the drawings. You won't need to guess what you need, but they will change maybe over time as the design develops. The number of parts may change, but largely they'll stay the same. Especially this frame. I mean, there's not a lot you can change about a frame, so once it's together sort of thing. So make sure that this long beam always goes to the top and to the bottom. That covers the full length. Oh dear, I made a mess already. That didn't last long, did it? Oh dear. Right, I think I can probably improve my method here. So the best way to do it would probably be screw in there, get a nut prepared, then put the Loctite on, just on the end, and then put the nut on there. And that's then ready to assemble into the frame. So if I now go ahead and do a bunch of those, I can then put this frame together after I've done that. Okay, it's coming along well. So we've got, oh dear, that's going to Loctite that shut. Oh well. So we've got a bunch of these now, and we can start putting something together. So all we do is slide the nuts into the frame and then tighten it up. It's quite important, in fact I'm going to go with very important, to get these square. Not only square, but equal lengths, equal parallelism. It's just what you do now with the frame will basically determine the quality of your prints. If it's slightly skewed, then your prints will come slightly skewed. So let's look at this corner. we want to make sure that that meets exactly with that edge and that meets exactly with that edge. So what we're going to do is take a spare piece, well it's not spare but it's not needed for the frame, and we're just going to butt that up against there, and that will mean that that edge has something to push into. Now we can sort of force it all together as we screw it, and that will mean that the whole lot stays square and all that sort of thing. So that's now just finger tight with that. And there you go, that's now very slightly off. Bit of a push. It's a horrible sound, but there we go. So that now we know is square, it's flush, it's whatever. And then once we've done that, we can come along with this nice long-headed, long-legged Allen key, whatever they call it, and just tighten those nicely. That'll give us a nice strong joint that won't move at all. So if we were using the plastic nuts, for example, you could then push this inwards and that would pull that joint apart, but I think with metal ones that's not going to be happening. Probably does, probably would if you do it very hard, but that would also be silly. You also want to check that this face is flush, so do it on a flat table if you can. That will help you, that'll get you a long way in making sure it's flat and square, flush, that sort of thing. So now let's move along to the next one. So again, this is a longer one, this is a 400, these are 440. And same deal, slide this in the end. We want to actually, before we do that, we're going to put some slot nuts in the bottom of here. So let's have a look at this. Once you put that slot nut in there, well, if you can get it in, there you go. Once that slot nut is in there, and there's one the other end, you can't get one of these in here. You can't just slide it in. That's what the post-fit assembly nuts are for. But we want to use these ones because they are better. They're going to last longer, they're going to be stronger, they're going to be more durable. So in order to make sure that we're using them for the internal sort of components, we want to try and put them in now. If we miss one, then we'll use a post-assembly, post-fit, post-assembly, whatever slot nut, the little, you know, these ones, and they'll work fine. But ideally, we want to try and get the big ones in where we can. So let's check how many we need. I think I'll try and add details for this to the drawing, because that way when you're putting it together, you won't have to go and look at the whole assembly and see what has to be done. You can just follow the guidance that's provided. Way! So this one's actually one of the few edges that doesn't need any additional nuts. Again, if you do want to sort of make your own additions to this, you can do, obviously. You can either just put them in as you build it, or if you're use it for a while and decide you want to add something, you can obviously use the post-fit assembly, post-assembly T-slot nuts, and they'll work fine. It's just best to get these in where you can. If your lengths are not the same, so mine, I pre-bought my lengths cut, so I know that they're accurate. I've measured them. They are all exactly the same, give or take, obviously very small amounts. But if they're not exactly the same, like if your 440s, for example, might be 441, 441 and a half, 440 and a half, what you can do is start at the bottom. Don't start at the top like I have here. If you start at the bottom, then let me show you how you can deal with this. So let's say this is one side of the frame, which it is. If you start at the bottom, you can obviously use this to get your 20mm distance, put your corner in here, and then measure where the top one should go. That way the print of size will all be the same and it will sit flat because you've done the base flush to the corners. And then when you get to the top, there will be sort of little extra parts at the top on each corner, which will stick up and be a bit sharp. Maybe print a little cap for those or something if you want to. But if they're all exactly equal like mine are, exactly equal, very close to being exactly equal, then you don't need to worry about it quite so much. So you can assemble it in this lazy order like I am. Or, if you want to do the lazy thing and just assemble it via that reference and then just measure top down, or just using this, you can then print little feet on the bottom to make sure it sits flat. But it is crucial to get this distance here to here the same. If this one's slightly longer, and you measure from here and then from here in, then that distance there is going to be slightly longer than that distance there. So you just got to be smart and measure from a reference point. Have a reference and measure always from there, always that way. Don't measure a little bit in there and then the other one's up there, because that will end up skewed and whiffy. So, do I have an exact length that fits in there? Because that would be quite nice. See, what you can do, because these frames are all very sort of uniform, you can actually use them to help build things square. You know what the lengths are. So I know this is 340, for example. So 340 plus 20 is 360, plus 20 is 380. So we're now at 380, and that all fits in there. And this one here, this long one, is the one we're clamping in. Obviously, this is now in the way. So maybe we could put the corner on the bottom. It doesn't really make any difference. Or you can measure up from the bottom. I mean, you can see probably how accurate these ones are. Mine are very well done, so they're nicely accurate. What am I going to do? They're actually not very... What's happened there? Something's not quite right. This. So if you put these flush like this, we can put another one of these in here, and that will be square against there. Put that distance with that, so that matches that here, so that's square. Another one in here matches that distance, so that's square, that's square. And now we've just basically moved our reference point, because this can't move. Well, it can move, but it's not going to change the dimension, whereas it's clamped up nicely. So we could put maybe a short one of these in the middle, and then that there. And that's now fixed, that reference point. So this is the one we're putting in. That's about 20 millimeters, but it's exactly the right amount from here, because we've measured it with this, this, and this. So you see how you can use the parts of the kit to make sure you're building your printer square. What you can do is check that distance if you like by sliding that in there. Mine's not as close as I was hoping. So that's for me probably a millimeter off, but it's exactly the same that side. So it's about a millimeter both sides. So maybe this one's slightly shorter than it should be. So if I measure this, ow, that is exactly 440. So, you know, there's lots of different ways to do it. I'm just going to use this way as I have it now. So this one will need extra slot nuts actually. How many do we need? We need an M3 and then two M5. So the M3 is a post-fit slot nut, so we don't need to worry about that. We just need two M5, two slot nuts. So these particular ones are going to be holding one of the XY stepper motors that obviously drive the Core XY kinematics. So all we need to do is slide those up in there, and then they're in there for use later on. It doesn't matter where, they obviously slide up and down. Anywhere in there, happy days. Now I can slide this corner on here, like so. Slide this corner on here. And again, at this point, consider, as you're putting it together, what slot nuts need to go where. So along the top of this rail, with this, some of these sides are always open, obviously. So we need two in this on the bottom. And those are going to hold the SSR mounting little box thing. And then along the top we need 1, 2, 3 and that's for the power supply and part of the control panel. How many did I put in there? 3, excellent. And up this side, we just need 2, I think. 2, 3. Another 3 up this side. So these hold the other end, the sort of the Y-axis shaft mount, and the third one holds the ramp's control board panel mounting bracket thing. So now we've got those filled, those filled. So the inside is the bottom. Along the top we've got those. This is the outside, we don't need anything there. So that's now ready to go together. All we need to do is again slot this in. Just so you know what it looks like slotting it in. So you're looking to take this, align it as best you can. It does help to sort of try and push the screw from the back. And then it just slides in like that. And then again for this edge, it gets a bit difficult here because... So what you can do is slide the whole thing that way while it's lowered off the bottom. Put it in like that. Yeah, come on. Not the easiest things to deal with. And then they're in. So that's now assembled. So again, remember using the reference and moving it using squareness and set lengths. Nothing ever needs to be super tight, you know, just sort of don't try and really wrench it, you'll end up bending the wrench, mucking that up, and it's just not necessary. That looks like it doesn't quite touch. Remember, it's important to make sure these are square. Right, and then your last corner to go. Excellent.